Okay, in the last lecture we started the topic of spot speed studies. Okay, and we started with the discussion that what are the conditions for fulfilling the spot, for doing the spot speed studies, and you have to keep in mind for your projects as well. Okay, where do we use the spot speed data? Some important definitions for the data. Okay, how do we collect spot speed data? You can do it manually or through detectors and counters. Once you have the data, you have to arrange it in the form of frequency distribution. You have to select speed groups and you have to write the frequencies with it. This is some basic calculation which you have to do, calculating frequencies and so on. Then you can draw these graphs. Okay, one is for frequency, the other one is for cumulative frequency. Two types of statistics can be calculated for the data: central tendency and dispersion. Central tendency gives you the center, the dispersion gives you the variation. Okay, so we discussed the first one. We calculated or found the first set of values which come under central tendency. So we found the mean. There is an equation to calculate the mean. For the rest of the values, we have these graphs. Okay, so the rest of the values include median, mode, and pace. Okay, so two are values, and this one is the range. Okay, now we'll go on to the other set of statistics, which is the statistics for dispersion. Okay, well, statistics for dispersion include, the first thing we will include as standard deviation. Okay, and we defined standard deviation earlier as well. Anybody remembers? How do you define standard deviation?
Difference between the average and the data.
Difference between the average and the data. The average of the difference between the average and the data. Okay? So you take the difference of data and the average and then you do the average of those differences. Okay, that will give you standard deviation. Now you see multiple equations of standard deviation. The first one here, the smaller one, is a simple equation, okay, which is applied to any set of values. I give you 10 values, 20 values, and I ask you to calculate standard deviation. You will use the first equation. Okay, so x is the value, x bar is the mean of all the values, and capital N is the number of values. Clear? So this applies to, if you have values, separate values, unique values, but we don't have this. In our speed data, we don't have values. We have speed groups and frequencies. So this cannot be applied. Okay, so then you go with this equation. Okay, now in this equation I have n. What was n?
Number of vehicles.
Where? Total number of vehicles for something,
Frequency.
for a specific, no, number of vehicles means frequency, but frequency of what? For the group. Frequency for the group. And what was S for the group? S is also for each group, right? What was S?
Speed.
Which is speed? Upper, lower, middle?
It was the middle.
Middle. Okay, middle is speed. So, number of values for each group, middle of each group. And X bar? Mean. Capital N? Total number of values. Total of n, right? If I do summation of n, it will become what? Capital N. Okay? Okay. So this is what they did here. They opened the bracket. They were having summation of n. They replaced summation of n with capital N. Yeah. So these two equations are same. They are different versions of the same equation. Clear? Okay? Any problem? Okay. Now, okay, so this is the equation we have, and if I go to the data, then we will have the values. Okay, So the equation requires n into s square, right? Do I have it? And the summation is also given, right? Okay, how much is capital N? 368. Okay. The only thing remaining is x bar, which was the mean. We calculated it last time. Okay. And it was 48.2. Okay. So the mean was 48.2. So how much will be the standard deviation? Tell me. Yes. How much? Summation given, right? Summation is given. What is that?
How much is one?
868,448. This whole thing is that summation, and n, which is 368, the next bar, which is this one, and this is 368 minus 1. And the whole thing is an square root. Yes.
486.2.
Still wrong. Yes. Why are you doing square? It's already square and everything. Yes.
Okay.
46.2.
Just put 868,448. Yes.
6.064. That's quite good.
Okay, I will tell you a check. The check is that the standard deviation should be less than the mean. Standard deviation should be less than the mean. Why? Because standard deviation is the difference from the mean. How can it be more? Huh? We said standard deviation is the difference from the mean, right? So how can it be more than the mean? Got it? Okay? So if it is more, then you need to check either your calculations or your data. Either your calculations are wrong or your data is wrong. Clear? Okay. So this is one measure of dispersion. The other measure of dispersion is percentage of vehicles which are in the pace range. Okay. Now pace is a range, right? What is the difference in this range? How much difference? 10. Okay, 10 miles per hour. Okay. And this 10 miles per hour was here. In the center. Okay. So the range itself is the central tendency, the center of the data. The range is the center of the data. But how many values are in the center in terms of percentage? This is dispersion. Okay, how many values are there? This is dispersion. What is the range? This is central tendency. Clear? Okay? Okay. So we found that the pace range was 42.5 and 52.5. Okay, how did we find it? You have to go back in time. Okay. But how do I find out the percentage? Okay, so percentage will use this graph, the second one, the cumulative frequency. Okay, my pace is between these two values, right? So I know the values. I want percentages, right? Okay, so I start from 52.5, the higher one. 52.5 is here, somewhere here. Okay, I go to the curve, find out the percentage. Okay, Now this is cumulative percentage for 52.5. Agreed? This is cumulative percentage for 52.5. Okay, and so it is somewhere near 70 something. Okay, it shows here somewhere 77%. Okay, and the other value is 42.5. Okay, again I will do the same thing. 42.5, go to the curve, find out the percentage. Okay, but these are cumulative percentage. Cumulative means what? All the previous values are added, right? So the percentage is not for 42.5, it's for all the previous value till 42.5. Okay, so this value is how much? 16%. So 16% is not at 42.5, it is all the values up to 42.5. So from 0 to 42.5, right? 16% from 0 to 42.5 and 77% for 0 to 52.5. Okay, now how many values between them? I'll take the difference. Okay, 0 to 52.5, this much. 0 to 42.5, this much. How many between them? You take the difference. Okay, and it comes out to be 61%. Clear? Okay. Now these are dispersion, right? Variation. Okay. So for my data, the percentage is 61. I take some other data, and in that data, the percentage comes out to be 55. So one data has 61, the other one has 55%. Which one has more variation? The one which has 61, the one which has 55%. Which one has more variation, more dispersion? 61 has more dispersion. Where is the 61? Where is my pace? Where is my pace? It's in which part of the data? Middle, right? So what is 55% will have more variation. Right now I have 61% in the middle. In the other data I have less in the middle, right? So the variation is more. Clear or not? Huh? Is that?
Just take it off. What and what? Take it off.
Which graph?
This one.
Which one? There are two. Top or bottom? The top one is between frequency and middle speed. The bottom one between cumulative frequency and upper speed.
Doctor, if it's close to 50, the variation will be more.
As the percentage goes down, there are less values in the middle. Means more values are outside. So variation is more. Okay? And what about standard deviation? I have a standard deviation of 6 here, right? Another data has standard deviation of 4. So which one has more variation? 6 or 4? 6 has more variation. Right? Because standard deviation is difference from the mean. Difference increases, variation increases, right? Okay? So this is how it works. Okay. The next thing is 15th and the 85th percentile. Okay, just give me a few seconds. I need to bring the chart. Okay. So 85th percentile I mentioned earlier as well. Okay. First of all, what do we mean by 85th percentile? Anyone? 85th percentile means what?
0.85 from the total value.
Okay, good enough. Okay. So this is the 85th value in the data. This is the 85th value in the data. Okay. So I have 85% data up to that value. Okay. And 15 percentile means what? This is the 15th value in the data. Okay. So 15% of the data is up to this value. Clear? Okay. Now what is the importance of 85th percentile for highway engineers? Anyone? Where do we use 85th percentile?
Design.
For design. Okay, our design is not based upon average, our design is not based upon high value, the highest value or the lowest value. It's based upon 85th percentile. Okay, we consider it to be the most reasonable value. Okay, or the highest reasonable value. Okay, the highest reasonable value. Clear? And the same thing for the 15th percentile. We consider it to be the lowest reasonable value. Okay, so anybody who is out of this range is more than 85th percentile or less than 15th percentile. Who is more is too high, and who is less is too low. Clear? Okay, so too high could be somebody who is somebody dying in the hospital. So he's going like crazy. Okay, or somebody who has too slow, maybe he has a problem with the car. Okay, or nothing to do in life. They are going too slow. Got it? Clear? But so we cannot design for these people. Okay? So we design for this range. Okay? So how do we find out the percentile? Percentile comes from the second graph always. All percentiles come from the second graph. Okay? So if I'm looking for what? I'm looking for the value, right? I already know the percentage. 85 and 50 is the percentage, right? So I'll go to the graph, 85%. Where is 85% here? Go to the curve, how much the value? I got the value. Okay. Same thing for 15 percentile. Go to the graph, curve, how much is the value? This is the value. Clear? Okay, so I got 85th percentile, I got 15 percentile. Okay? Now we are doing dispersion, right? Variation. Okay, so I got these values, this much. Okay, these are my values. 85th percentile, 15 percentile. Okay. Now, so for dispersion, I will take the difference between the values. Okay, now this one is very easy. If the difference is more, the variation is, the dispersion is, this means what? Yeah, variation is more or less?
More.
More. Okay, difference is more, right? Values are far from each other, that means variation of dispersion is more. Difference is less, variation is less. Clear? Okay. Another use of these values is to calculate standard deviation. There is another equation to calculate standard deviation. One is that one, and then this is the other one. Okay. Can you give me the value of standard deviation using this one? You have the values? How much standard deviation? What did I tell you? What did I tell you about standard deviation? What was the check? What is the check?
Less than the mean.
It has to be less than the mean. How can it be 48 point something? You are subtracting 54 and 42. How can it be 48? I was just telling the other section, I'm researching the ways of how, in how many ways you can go wrong in the exam. And every section, every class gives me something new. Yes. 6.14. Okay, and how much was that? 6.1. Okay. approximately. This was 6.0 something, you round it off. This is 6.1 something. So they are approximately equal. Okay, whether you calculate by this equation or that equation. There are two equations to get the standard deviation. This one and that one. Okay, this is the answer from this one, this is the answer from the other one. Okay, they are almost same. Fair? Okay, so the answer is almost same. Which one is easier? This one. Which one you will use?
This one.
That one.
Always.
Huh?
Always.
Always what?
You are complicating the things.
Yes.
It's a doctor.
Because life is
Complicate.
complicated. You know it better than me, right? My man. Okay. Clear up till now? Okay, so we have done 4 measures of central tendency and 4 statistics for dispersion. Oh, sorry, 3 statistics for dispersion. 4 statistics of central tendency: mean, median, mode, and pace. Okay. 3 statistics for dispersion: standard deviation, percentage of drivers in the pace, and the 85th and the 15th percentile. So the standard deviation was the value, then the other one is the percentage, and then this one is the range. Okay, so we have all these 3 things covered. Okay, when we plotted the data, okay, so you were asking me for the graph, right? So this is one of the graph. The graph is between middle speed and the frequency. Okay, the middle speed and the frequency. Okay, and this graph, the shape of this graph, okay, is what we call as normal distribution. This shape of the graph is called as normal distribution. Okay, if a frequency distribution, I told you what are we plotting? Frequency, right? If a frequency distribution graph looks like this, then we call it normal distribution. In the previous chapter, in the first chapter, we looked at a graph like this between speed and density. You cannot call that normal distribution because that is not frequency. If you draw the graph for frequency, then it looks like this. Then you can call it normal distribution. Okay. Now, what makes it normal distribution? You see there is a peak, right? There is a peak. And only one peak, right? It doesn't go up and down. It goes up and then down once. Okay, so there is one peak only. And the second thing is, where is the peak? Almost in the center. The peak is almost in the center of the curve. Okay, so a graph which follows these 2 conditions for frequency, then we call it what distribution? Normal distribution. Okay, so the graph is for frequency. It has one peak. And where is the peak?
In the center.
In the center. Clear? And you call it normal distribution. So instead of writing that data follows normal distribution, because that will be easy, right? We want to make it complicated. Okay, so you write it like this. This says X follows normal distribution with a mean of 40 and a variance of 25. Okay, now what is variance? Variance is the square of anyone?
Standard deviation.
The standard deviation. Okay, so you have a standard deviation. If you take the square of this thing, it will become variance. Or remove the square root from here, it will become variance. Clear? Okay. Now, if I want to write the same statement for my data, okay, then I will write it as, now my data is a speed, right? So S, N. What's the square of this? Okay. Now, how do we read it?
Speed is normal.
Speed is normal distribution. Mean of 48.2 and a variance of 37.2. Clear? Huh? Okay. So why we are, okay, so if you go back to the first lecture, I told you that, and you can see in the graph as well, the curve is not joining all the points, right? The curve does not join all the points because I'm looking for the shape. Which shape? Now I know this shape is called as normal distribution. Okay. Now why I was looking for normal distribution? This is a rule, a principle, scientific principle. If you take real data and you take enough values, then the frequency should be in this shape. Okay. If the data is real, and you have enough values, then it follows this. The shape should be this.
If it is not,
If it is not, the shape would be not this.
it's cool.
See, they thought about you as well many years ago. Gazder will come in 2025 and he will ask me this. Clear or not? Okay. So this is why we are looking for the shape, and this is why we made the best fit curve, not the curve joining all the points. So if you join all the points, it will go up and down. Okay. Now, I told you how to read this, right? How do we read this line? How do we read this? Z, normal distribution,
Upon
mean of
mean of 0.
0 and
variance
variance
of 1.
of 1. Okay? If our data follows all these three conditions, there are three conditions here, right? What is the first condition? Normal. What is the second condition?
Mean 0.
Mean 0. What is the third condition? Variance of 1. If our data follows all these three conditions, then we call it a standard normal. My data, how many conditions does it fulfill? My data. How many of these? One. So I can call it normal, but I cannot call it standard normal. Okay. Standard normal must fulfill all these three conditions. Okay. So it's a well-known distribution, and they always represent it with Z. The standard normal data is always represented with Z. So if you go in the frequency or statistics book and you see a distribution, it's mentioned as Z, it is this distribution. Clear? Okay. Now what is important about, or why are we discussing this standard normal? Because standard normal is predefined. It's fixed. Standard normal is fixed. So remember we were doing 85th percentile, 15th percentile, median, mode, this and this. Okay. So every time I have to go to the graph and find out the value, right? And if my data changes, the value will change. Standard normal doesn't change. So somebody tells you standard normal. How much is 15th percentile? Today it is this much, tomorrow it is this much, after 100 years it will be the same. Okay, and from where can I get it? Anywhere. You always have the same value. There are tables available, you go search online, you will find the tables for Z. You go in Excel, you will find a command for finding out the value of Z. Okay, you go in MATLAB, you look for normal distribution, you always get the same value. Okay, so having a data which follows these three conditions makes my life easy. Okay, but the problem is this is easy but not real. This is easy but not real. Why not? Because of zero mean. How can I have zero mean? No? For speech, how can I have zero mean? Okay, or weather data, how can I have zero mean? Especially in Bahrain. It doesn't go below zero, right? Maybe in Canada they have minus and plus both, but we don't have 100. Okay, so this is easy but not real. That one is real, but then it needs more work. Okay, so they have found a way to convert the data into standard normal. This is the way. Okay, so you take the value minus mu. Now this equation is the standard equation you will find in the statistics book. Okay, so it is written in the as it is to avoid any confusion. Okay, so x is the value you want to convert, mu is the mean of those values, and sigma is the standard deviation of those values. Okay, so for example, if I want to convert, I have a value in my data 35. One of the speeds is 35. Okay, I want to convert into z value. So z for 35 will be 35. Okay, now I need the mean, right? How much is the mean? 48.2. Okay, divide by standard deviation. How much is the standard deviation? 6.1.
Minus 2.2.
Clear? Okay. So you want to do the analysis using the Z table and the Z everything. Okay. But you have real data which doesn't have a mean of 0. So you can convert the data into Z and then you can use the Z table. Now I took the data and I did with all the values like this. So all the values are now Z values. Okay. Now somebody asks me for 85th percentile, 15th percentile, I don't need to draw the graph. Okay. I don't need to do the graph. I'll go to the Z table and find out. Clear? Okay. Two more important parts for normal distribution. They are for normal distribution. Okay. Everything now we are discussing is for normal distribution. Okay. The first part is related to the error. The capital E is what you call as a standard error. Okay. So error tells you about what? Error tells you about what?
The role of the values.
Huh?
The role of values.
When error increases, what decreases? Increase in error means decrease in quality. Give me another term. Quality. Accuracy. Okay. So this is the equation which you see on the top, which tells you about the expected error of your sample. The standard error is like how much error can I expect in my sample. Okay, error is always expected. Okay, error is always expected. You cannot know the exact value. Why? Because there are two types of errors: systematic and random. So random error is not always exactly known. Clear? Okay. So we come up with different methods to find out the error. This is one. Okay. So capital E is standard error. S is the standard deviation of your data, and N is the number of values in your data. Clear? Okay. Standard deviation of the data. Standard deviation of the data upon root of number of values in the data. Clear? Okay. Now my data has a standard deviation of how much? 6.1. And it has how many values? Okay. So now what is the standard error of my data?
0.1 is 0.5 also.
3 So 0.32. Come on. Clear? Okay. The expected error of my data is this much. Okay. Another thing which is related to normal distribution is the central limit theorem. Central limit theorem. Okay. Central limit theorem tells you that if you have normal distribution, now normal distribution we said is this, right? Okay, peak in the middle. So from the middle, if you go 1.96 times E on each side, E is what? Okay. So Now, center means the mean, right? Center is the mean. Okay. So from mean, go 1.96e plus and 1.96e minus. You will get a range, right? You will get a range. This range should cover 95% of data. This range should cover 95% of data. Okay. Whatever are these values? For example, this is 40 and this is 50. So 95% of the values are between 40 and 50. Clear? Now you can make it more precise. If you do 3 times of E, then how much value or how much data you will cover? 99.7%. Okay, this is according to central limit theorem. When the graph is what distribution? No. Clear? Okay. Now, can you give me the range for 95% here? How much will be the range for 95% for my data? You can see the equation over here. Mean plus minus 1.96 E. Okay, 95%. Okay, so my mean was 48.2. I want to do plus minus 1.96 and my E value is 0.32, right? So how much is that?
48.8.
48.8 and sorry, 0.8 and 47.6. Okay. So 95% of the values are in this range. 95% of what? 95% of all values. 95% of all values. Do I have all values? No. I have how many values? 368, right? Okay. Is 368 total? No. It is total of this sample. Okay. But you started the study, there were drivers before you, right? When you finish the study, there are drivers after you. Okay. And you have already done the study for your projects as well. So when you were doing it for one car, there were other cars as well. So even in the same time, 368 is not the total. But this range is for the total. Clear? Clear? Okay. Now, the range is called as confidence interval. The range which you have calculated is called as confidence interval. Okay. Now this range is for how much percentage? 95. Okay. Can I increase it? Yes, I can go up to 99.7. And for that, I will replace 1.96 with 3. Okay. So I will get another range, right? That will also be called confidence interval. That will also be called confidence interval. But what percentage? 91%. Okay. So the percentage is called as confidence level. The percentage is called as confidence level. And the range is called as confidence interval. Okay. So for every confidence level, I have a range. Okay. The confidence level which we have studied are two, 99.7 and 95. The range for 95 is the confidence interval of 95% level. The range for 99.7 is the confidence interval for 99.7% level. Clear? Okay. Percentage confidence level, range confidence interval. Clear? Okay. So I'll continue from here more inshallah. Okay, so we did not calculate 99.7%. You can do it yourself.